In recent years, the battlefield balance in Eastern Europe has continuously evolved, shaped by advances in missile technology, intelligence, air defense, and long-range precision strikes. The video, British Nightfall Changes Everything, new 500-kilogram missile leaves no base safe in Russia, signals a significant leap in Britain's support and strategic posture, especially regarding how Russia's rear areas and ostensibly safe bases might no longer be beyond reach. Below, I analyze the strategic implications of introducing such a missile into the theater, what it means for Russia, for Ukraine, and for the broader dynamic of deterrence. 1. Altering the concept of safe rear bases. One of the foundational assumptions in war is that certain rear installations, supply depots, logistics hubs, command and control centers, remain relatively secure from frontline weapons. Typically, they benefit from distance, layers of air defense, geographic obstacles, and the political cost of escalation. But a missile with the range, precision, and warhead size suggested by Nightfall, 500 kg class reshapes those assumptions. Extended reach. If Nightfall can strike deep into what were formerly secure zones, it forces the adversary to reallocate air defense assets farther from the front line, diluting coverage. Dispersion pressure. It compels the opponent to disperse logistics, use redundant and mobile sites, and invest in camouflage, decoys, and hardened shelters. Psychological deterrence. Knowing that no base is absolutely safe imposes a constant tension on commanders and planners, complicating their calculations of where to place command posts, maintenance centers, missile stockpiles, and intelligence nodes. In short, a weapon like Nightfall erodes the safe rear sanctuary, turning previously low-risk zones into contested airspace. 2. Escalation and risk management. Deploying or even demonstrating a capability such as Nightfall carries risks of escalation. Russia may interpret strikes or implied threats against its territory or deep bases as crossing a red line. This opens several dilemmas. Tit-for-tat escalation. Russia might respond with more aggressive strikes using its own long-range arsenals, possibly broadening the conflict geographically. Diplomatic backlash. Allies and neutral states may worry about stability or the risk of miscalculation. Retaliation pathways. Russia may target not just military assets but critical infrastructure, energy, communications, as asymmetric retaliation. Thus, the decision to employ Nightfall, or publicly publicize it, must walk a fine line, applying pressure without triggering uncontrollable escalation. 3. Force multiplication for Ukraine and allies. From Ukraine's perspective, integrating a missile like Nightfall offers a force multiplier effect. Strategic strike capability. Rather than being reactive, Ukraine, supported by Britain, can proactively target high-value logistical nodes, rear depots, command centers, undermining Russia's sustainment. Disruption of supply chains. Strikes deep behind the lines could hamper Russia's ability to move ammunition, fuel, spare parts, or reinforcements reliably. Psychological impact on troops. Knowing that rear areas are vulnerable may reduce morale among Russian troops and complicate their planning. Cost imposition. Russia must invest more in defenses, redundancy, and complexity, diverting resources from offensive operations. Hence, Nightfall becomes not just a weapon, but a strategic lever, shifting the offense-defense balance deeper into the territory of the stronger power, Russia. 4. Countermeasures and evolving defenses. No weapon system remains dominant forever. In response, Russia and others may adopt countermeasures. Improved air defense integration. Layered systems combining short, medium, and long-range interceptors, ideally networked via sensors, radars, and drones. Electronic warfare and decoys. Jamming, spoofing, reflector balloons or decoy emitters to mislead guidance systems. Mobility, concealment, and mobility, mobile and hidden infrastructure that is harder to detect or target reliably. Counterstrike deterrence. Threats to retaliate on launcher sites, supply nodes of the attacker, or adjacent bases. In the face of Nightfall, Russia will likely re-architect its defense posture, possibly adopting more dispersed, resilient logistics, and investing heavily in sensor fusion to detect incoming missiles earlier. 5. Strategic messaging and credibility. The public revelation of Nightfall serves as a signaling tool. It is not just about the missile's physical capability, but about the perceived will to use it. Deterrence through ambiguity. Britain and its allies may choose to keep certain performance details undisclosed, thereby forcing opponents to assume worst-case scenarios. Alliance reassurance. Demonstrating that allies are willing to invest in advanced strike capabilities sends a message of commitment. Deterrence of third parties. States considering intervention or escalation might think twice if they believe they, too, are within range. However, credible use is key. The missile must not be just a prop, its deployment, tests, and possible limited use in wartime all contribute to making the threat real. Part 2. Technical challenges, operational risks, and wider geopolitical effects. In Part 1, I laid out how Nightfall shifts strategic balances. In this second part, I examine the technical challenges of such weapons, the operational risks of using them, and the broader geopolitical ripple effects such systems may engender. 1. Technical and logistical challenges. Developing, deploying, and sustaining a missile like Nightfall is non-trivial. Some of the critical challenges include guidance accuracy and countermeasures. To hit high-value targets deep behind enemy lines, the missile must resist jamming, spoofing, and terrain masking. Propulsion and range trade-offs. To carry a 500 kg warhead over medium to long distances, the missile needs an effective propulsion system and fuel capacity. This often conflicts with stealth or small radar cross-section goals. Survivability of launcher systems. Launchers must be mobile, hardened, or concealed, they themselves become high-value targets. Logistic support and maintenance. Precision missiles need upkeep, alignment, calibration, spare parts, and secure munitions supply chains. Intelligence, surveillance, and reconnaissance ISR. Precise targeting requires up-to-date intelligence on base layouts, defenses, movement, often from drones, satellites, signal intercepts, etc. Integration with command and control. To prevent fratricide or misuse, the missile's launch must be integrated into secure, reliable command networks. Overcoming these technical challenges demands sustained R&D, investment, and operational discipline. 2. Operational risk and collateral concerns. Using long-range precision weapons comes with risks, mistakes in targeting, failures, or unintended consequences. Collateral damage. If intelligence is wrong or a base is adjacent to civilian areas, strikes may cause civilian casualties or infrastructure damage, invoking political backlash. Faulty munition failures. Missiles can miss, malfunction, or leave unexploded ordnance behind, complicating cleanup and morale. Escalation miscalculation. A strike that's seen as too deep or too destructive might provoke disproportionate retaliation. Detection and preemption. Launching forces might be located, targeted, or neutralized before they fire, especially if their patterns become predictable. Signal intelligence leakage. Communications or sensor emissions during operation can betray methods and allow the adversary to adapt. Thus, operational planners must be cautious, selective, and employ strict rules of engagement and backup intelligence validation. 3. Geopolitical and diplomatic fallout. Introducing a weapon of this magnitude reverberates far beyond the battlefield into diplomacy, alliances, public opinion, and arms control. Arms race acceleration. Russia and possibly other nations may accelerate their own missile development, hypersonic programs, anti-satellite weapons, or long-range hypersonic glide vehicles. Arms control tension. Such advanced missiles could complicate existing arms control regimes, triggering calls for new treaties or restrictions. Regional security shifts. Neighboring states may feel threatened if the missile's reach overlaps their territory, prompting them to beef up defenses or realign alliances. Escalation risk to strategic domains. Strikes deep inside Russian territory could push Russia to retaliate across domains cyber, energy, space. Domestic opinion and political pressure. If a weapon becomes controversial due to collateral damage, cost, or perceived escalation, governments may face internal pushback. Therefore, states deploying Nightfall-like systems must balance the military advantage with diplomatic and political prudence. 4. Potential scenarios. Use cases and constraints. To envision how Nightfall might be employed, consider a few possible scenarios, along with constraints. Preemptive strikes on critical logistics nodes. Early in a campaign, Nightfall could target fuel depots, rail hubs, or missile supply lines deep behind enemy lines to disrupt momentum. Constraint. Requires precise intelligence and must avoid hitting civilian or dual-use infrastructure. Command post suppression. Striking command and control nodes to degrade decision-making and force reconstitution. Constraint. Command posts are often mobile, hardened, or dispersed, locating them is difficult. Counter-battery or support strike. Targeting repair facilities or missile production, logistics centers that support frontline artillery or rocket forces. Constraint. Those are often intermingled with civilian areas or within layered defense zones. Demonstrative or deterrent strike, a limited show of force against a lightly defended target to send a signal. Constraint, must avoid escalation, ensure minimal collateral damage, and maintain plausible deniability or calibrated messaging. Combined operations with air or UAV platforms, Nightfall may be used in tandem with drones, surveillance, and conventional air strikes to overwhelm defenses. Constraint, coordinating timing, deconfliction, and minimizing interception risk become complex. Each scenario must be weighed against intelligence certainty, risk thresholds, and strategic goals. 5. Long-term effects on warfare in the region. Finally, introducing Nightfall has potential long-term impacts on how wars are fought, especially in contested, high-intensity theaters like Ukraine-Russia. Normalization of deep strike warfare. What once was the domain of strategic, nuclear-capable missiles may now enter conventional warfare, meaning deep strikes become routine. Focus on anti-access, area denial, A2AD. Opponents will invest heavily in denying missile ingress, via layered missile shields, decoys, directed energy, and sensors. Operational tempo increase. The pace of action accelerates, with sides needing to rapidly move, conceal, relocate, and anticipate strikes. Greater reliance on ISR and data fusion. Battles become data-driven, those who dominate sensing, processing, and dissemination gain a major advantage. Hybrid warfare intensification. Cyber, electronic warfare, deception, and disinformation will blend more tightly into kinetic operations to mask or confuse missile targeting. In this way, Nightfall is not just another missile, it represents a step toward an evolving warfare paradigm, where deep precision strike is a core component of the conventional toolkit. If you like, I can refine this text to focus more on technical details, or convert it into a narrative or speech. Do you want me to merge the two parts into one polished essay, or to break them down into separate downloadable files?